Welcome busy Round Rock ISD 4th grade teachers. We know your planning periods are practically non-existent, and you've got a million things on your plate, so this explainer for your upcoming Unit 2 on the properties of matter is going to get straight to the point. We've put together absolutely everything you need to confidently walk into your classroom and guide your kids through this incredible science unit, completely skipping the part where you spend your entire weekend reading a mountain of curriculum documents.
Okay, let's dive right in. Over the next 21 sessions, it's all about empowering your students to classify and describe the messy, wonderful physical world around them. And what's really special about teaching this in 4th grade is that this is the exact age where kids transition from just playing with stuff to actually analyzing it scientifically. They're naturally so curious, and this unit really harnesses that energy. Plus, the best part, you absolutely do not need a physics degree to teach this. The curriculum gives you the structure, and we're going to break down the essentials so you can just focus on the fun part, teaching.
All right, here is our roadmap for today. We're hitting the unit TEKS, the core science, common misconceptions, investigations and modifications, and finally, the vocabulary and interactive word wall.
Let's start with Section 1, the unit TEKS, and look at what the end goal actually looks like.
Here's the exact wording for TEKS 4.6a. This is the foundational standard for all 21 sessions of this unit. The focus here is entirely on observable physical properties. Basically, what I like to call the Big Five: temperature, mass, magnetism, relative density, and physical state. Literally everything your students do, every lab, every vocab word, every journal entry, it all ties directly back to this one standard. They're going to test these 5 properties over and over until it becomes second nature.
So, what does mastery actually look like? By the end of this unit, your students will move way beyond just guessing. They'll measure, test, and collect accurate data using real tools. But the big takeaway is how they use that data to write clear claim, evidence, and reasoning, or CER explanations. A mastery-level response sounds something like, I claim the cork has a lower relative density than water. My evidence is that it stayed on the surface when I dropped it in. My reasoning is that objects with lower density float. It's all about shifting them from passive observers into active scientific thinkers.
Moving on to Section 2, let's confidently unpack the core science.
First up, physical states and temperature. Students need to grasp that matter keeps its shape as a solid, and it flows as a liquid. But crucially, temperature is the driver here. For instance, they must recognize that 0 degrees Celsius is the freezing point of water. Quick pro tip for you. Remind your 4th graders that in science, we operate in Celsius. They hear Fahrenheit on the morning news all the time, but scientists use the metric system. So we want to build that habit right from the start.
Next is mass. You'll help students understand that mass tells us exactly how much matter an object contains. We use balances and digital scales to measure it precisely in grams. You really want to emphasize why just holding 2 objects in your hands is super inaccurate. Human hands are basically terrible scales. Our brains easily get tricked by the size and shape of an object, which is exactly why we rely on scientific tools. Then we have relative density. Now, I know the word density can sound a bit intimidating to a 9-year-old, but in 4th grade, relative density is just a fancy way of describing how something behaves in water. Does it have greater density than water and sink, or lower density and float? That's literally the whole shebang. Demystifying these big terms really helps build their confidence. Finally, there's magnetism. Students will discover that only very specific materials have the physical property of being pulled toward a magnet. It's a super engaging, hands-on concept. But, as we'll see in just a second, it definitely comes with some predictable cognitive traps we need to watch out for. Which brings us to Section 3, Common Misconceptions. The curriculum actually includes Paige Keeley's probes to help catch these. So let's look at the big ones. During the ice melting investigation, you're going to have kids who think the ice just vanished into thin air. You'll need to gently redirect them to see that the solid simply changed into a liquid state. The matter is conserved, it just looks different. A brilliant way to prove this: weigh the cup of ice before it melts, and then weigh it again after it turns to water. The mass will be exactly the same, proving the matter didn't actually go anywhere.
Now this is a big one, breaking the assumption that big means heavy, or heavy means it sinks. You'll want to consistently route students back to measuring mass on the scale and testing relative density by actually putting the object in the water. A great analogy is reminding them that a massive, incredibly heavy cruise ship floats beautifully, while a tiny little pebble drops straight to the bottom. Relative density is what matters, not just overall size.
And that same kind of logic applies to the magnetism trap. Make sure to reinforce that weight has absolutely nothing to do with magnetic attraction. Plus, not all shiny metals will stick to a magnet. You can easily prove this by having them test a piece of aluminum foil or a copper penny, which totally won't stick, right next to a steel paperclip, which will snap right to the magnet for sure.
All right, Section 4, Investigations and Modifications. Let's talk about the actual hands-on action and how to support all your learners.
In the Icy Ice Lab, you'll need cups of ice, thermometers, and stopwatches. Students will measure and draw the ice after 3 minutes, and then again after 20 minutes out in the sun. This gives them concrete data to write their CER about temperature-changing physical states. Oh, and a quick safety note, remind them right out of the gate not to eat the ice. We treat these as scientific materials, not snacks. For the mass investigation, you're setting up digital and balance scales so kids can measure everyday classroom objects, erasers, rocks, paper clips, in grams. It takes this abstract idea of mass and makes it completely tangible. Huge management tip here, though. Explicitly teach them how to zero out or tear the digital scales before they put objects on them. Taking 5 minutes to teach that will save you a massive headache later. Trust me.
For the Sink and Float Lab, management is absolutely key. Have your clear tubs prepped and a stack of towels ready for the inevitable spills. Have students observe their dry objects first, make their predictions, and then, this is the important part, insist they gently place the items into the water. We want a scientific test, not a giant splash zone. The great thing is, it's incredibly easy to modify these labs. To support your emergent bilinguals or anyone needing differentiation, lean on the curriculum's provided sentence stems, like, I predict the blank will sink because blank. Put visual vocabulary cards right at their tables and write word banks on the board for the CER writing process. Science is for everyone, and these small tweaks make sure everyone can access it.
Our final stop is Section 5, Vocabulary and the Interactive Word Wall. How do we make this new knowledge stick? These are the high-frequency words your students most internalize by the end of the unit: matter, physical state, temperature, mass, relative density, and magnetism. They literally can't write or speak effectively about their claim evidence reasoning without them.
So how do we shift the interactive word wall from just being a pretty poster to an active classroom tool they actually use during investigations?
Well, the curriculum actually gives you a script, and you definitely don't want to just print cards and staple them up. It sounds exactly like this. Scientists, today we are going to add a new word to our interactive word wall. The word is mass. Let's create a definition together based on what we just observed in our lab with the digital scales. What did we measure? You let them generate the definition, draw the illustrations together, and literally tape up physical examples directly from your labs.
You have absolutely everything you need in the lesson plans to guide this brilliantly. So, the final thought I want to leave you with is this. How will empowering your students to truly measure and test matter transform the way they look at the everyday world long after they leave your 4th grade classroom? You are quite literally building future scientists here. Have a fantastic time teaching this unit.